In this lesson, we will talk about how to solve trigonometric equations. Trigonometric equations are just equations that have trig functions in them. So when we're solving trigonometric equations, we will often look for solutions over a specified interval, such as the interval from 0 to 2 pi. Okay, the interval could be anything, but more often than not is the interval between 0 and 2 pi. However, just as often, we will be asked to find all possible solutions over the entire real line, not just the interval from 0 to 2 pi. And because trigonometric functions are periodic, meaning remember, that means they repeat themselves, that means there are typically infinitely many solutions. There's an infinite number of solutions. If a particular interval is not specified, then we're going to understand that they mean find all possible solutions over the entire real line. Here are 4 things that we should keep in mind when solving trig equations. The first one is that the sine, the cosine, the secant, and the cosecant are periodic functions with period 2 pi, while the tangent and the cotangent are periodic with period pi. So all the trig functions are, basic trig functions are periodic with period 2 pi, except the tangent and cotangent, which are periodic with period pi. Okay, the next thing you need to keep in mind is that even though sine and cosine are periodic with period 2 pi, the zeros of these 2 functions actually repeat more often than 2 pi. Namely, they repeat with period 2 pi. Pi. Remember, first of all, what the zeros of a function are. The zeros of a function are basically just the values of x that make the function 0. The values of x such that when you plug them in the function, you get 0. So for example, if my function was x squared minus 4, then the zeros of f would be plus or minus 2, because those are the numbers that when you plug them in here, you will get 0. Now, so what do we mean by this statement here? The zeros of sine and cosine repeat with period pi. Well, for example, if you look at the graph of sine, note that the zeros, which in terms of the graph is just the points at which the graph cuts the x-axis, are these numbers right here. And so you have a 0 at 0, the next one is at pi, the very next one is at 2 pi, the very next one at 3 pi, the very next one at 4 pi. So you see they actually do repeat every pi. So every pi you have a 0, both to the right and to the left. To the left would be negative pi, negative 2 pi, negative 3 pi, etc. So the zeros, again, of sine and cosine repeat with period pi, even though the graph as a whole repeats every 2 pi. Okay, that's important to keep in mind when solving trig equations. The next thing we need to keep in mind is that when finding all the solutions of a trigonometric equation, first thing we're going to do is we're going to find all solutions in the interval from 0 to 2 pi, in the unit circle. Okay, so this is typically how we proceed when we're solving trig equations. You find all the solutions in the interval from 0 to pi, which really means all the solutions in the unit circle, and then you use periodicity to find the rest of the solutions. And lastly, these things you will understand them better once we get to the example. But okay, the last thing is it is generally recommended to write the equation in terms of sine, cosine, and tangent only. Write the equation in terms of sine, cosine, and tangent only. These are the basic trig functions that are easiest to deal with, so that's why it is recommended. So for example, if you were solving the equation secant of x equals 2, suppose that that's what we want to solve. We want to solve the equation secant of x equals 2. I would take a moment and try to write it in terms of sine, cosine, and tangent only first. So this one, secant is 1 over a cosine, so this would be 1 over cosine equals 2. And then if you take the reciprocal on both sides, so flip both sides, you would get that cosine of x equals a half. And this equation is actually much easier to solve than this one. Okay, we're more familiar in general with cosine and the special values, the values of the special angles and so on, than the values of the special angles for the secant. So that's why this is a lot better. Okay. All right. So let's solve the first example. It says find all the possible solutions of the equation cosine of theta equals a half. Cosine of theta equals a half. So we're going to find all possible values of the equation cosine of theta equals a half. Okay. So this is actually a value that comes from one of the special angles. So you have to recognize that in this case. Cosine, there is a special angle whose cosine equals a half. So what is it? What is an angle whose cosine is a half? Do you know? Well, you should know this one. So one in the first quadrant, it would be 60 degrees or pi over 3. We generally want to give the answers in radians unless they ask us to give the answers in terms of degrees. Okay. So the convention will be give the answers in terms of radians. All right, so that's one angle, okay? That angle satisfies this equation. Cosine of pi over 3 equals a half. So we found one solution. They're asking for all possible solutions. And according to this guideline here, when finding all the solutions of a trigonometric equation, we're first going to find all solutions in the unit circle, and then we're going to use periodicity to find the rest. Okay, so that means we found one. Let's make sure that we get all the solutions in the unit circle. So for that, we are going to draw a picture of the unit circle. Okay, and we have one solution right here. Right, this is pi over 3. The cosine of that angle is 1/2. Now, what is another angle in the unit circle that has the same cosine? What is another angle on the unit circle that has the same cosine? Well, cosine, if you remember, it associated to the x coordinate. So what is the question could be rephrased as what is another point on the unit circle that has the same x coordinate? Okay, the same x coordinate. So draw a vertical line through this point right here. And then this point on the other side would be a point on the unit circle that has the same x coordinate. These 2 points have the same x coordinate. So that means the angle that I want is this one. That's the angle that I want. Okay, and I'm measuring this way instead of that way because I want to find, as the guidelines clearly states, all the angles between 0 and 2 pi. So I don't want to measure it negatively. I don't want to measure it this way. I want to measure it that way because I want the answers measured positively between 0 and 2 pi. All right, so what is that angle then? What is that angle? Well, it's almost a full revolution. It's almost 2 pi minus this piece. This piece is pi over 3 because it's symmetrical. So that means this would be what? This would be 2 pi minus pi over 3, which is 5 pi over 3. So that is the second angle that satisfies the equation. Okay, so these two are the solutions. So the solutions in the unit circle, so namely between 0 and 2 pi, okay, that's what that means, are pi over 3 and 5 pi over 3. Okay, so that's the solution in the unit circle. Now to find all the solutions, because the solutions repeat every 2 pi, all you have to do is this. You're going to add all the multiples of 2 pi possible. How we write that? We write it like this. You add 2 pi, but actually all the multiples of 2 pi. You could add 2 pi, add it again, that would be 4 pi, etc. So this is how we write that. We write pi over 3 plus 2 pi n, where n is an integer. And then you do the same thing for the other one. Okay, again, that's because the function cosine is periodic. So these solutions, if you add 2 pi, actually also work. Right? If you have an angle here that works, if you add 2 pi to it, it's also going to work because adding 2 pi doesn't really change the value. The function is periodic with period 2 pi. So then these are all the solutions. You find both solutions of the unit circle and just add 2 pi n. Okay, where n is just any integer. Where n is an integer. Any integer. It could be positive or it could be negative. Alright, so that's the answer. Alright, let's do another one. Okay, it says find all the possible solutions of the equation sine of theta equals square root of 3 over 2. Okay, again, first of all, we find all the solutions in the unit circle. That one is, again, something that you should recognize as a special angle. The value of a special angle. So what is the theta? What is the special angle theta such that the sine equals square root of 3 over 2? It is pi over 3 again. Yes, pi over 3. Sine of pi over 3 equals square root of 3 over 2. Okay, now we found one. Let's find another. Let's find another one. Let's find all the solutions in the unit circle. So draw your unit circle. Draw pi over 3. And now let's figure out all the solutions to this equation. All the points on the unit circle that have the same sign. Sign is associated with the y-coordinate. So now I want another point that has the same y-coordinate. In other words, it's at the same height. And this would be it. This is another point in the unit circle, this one right here, that has the same y-coordinate. So that means the other angle that satisfies this equation is this one right there. This one right here. So what is that angle? That angle is 2 pi over 3. Okay, it's almost pi minus this piece, which is symmetrical to that one. So it is pi over 3. So pi minus pi over 3, which is 2 pi over 3. So now I have all the angles in the unit circle that are solutions to this equation. So the solutions in the unit circle or in the interval between 0 to 2 pi, parentheses, are pi over 3 or 2 pi over 3. Either we're asking for the solution between 0 and 2 pi, that would be the end of the story. But they want, again, all possible solutions. So all you have to do then is take these two and add 2 pi n, and that would be the end. So take each of these and add 2 pi n. So pi over 3 plus 2 pi n, and do the same for the other one. 2 pi over 3 plus 2 pi n. And we're done. Okay? N again is any integer, positive or negative or 0. That's the end. Okay, let's do another example. This one right here says find all the possible solutions to the equation 6 square root of 3 cotangent of x minus 6 equals 0. Okay, this has a cotangent, which I don't like that, right? The guideline says stick to sine, cosine, and tangent, the basic 3. So that means the first thing we want to do, one of the first things we want to do is try to rewrite this using either sine and cosine or tangent. Now, because it's a cotangent, what I would do is change it to in terms of tangent only. Not in terms of sines and cosines, because then you have two trig functions, and it is easier to deal with only one trig function than with two. So just leaving it in terms of tangent instead of cosine and sine is easier. Okay, so let's do that as our first thing. Let's solve for cotangent. So let's move the 6 to the other side. So this is going to be 6 square root of 3 cotangent of x equals 6. Okay, I move the 6, it becomes positive. Now divide by this. So let's divide by these coefficients. So it's going to be 6 square root of 3 cotangent of x equals 6. And now we divide both sides by that. So that goes away on this side, and we have this. We can cancel those 6's. So we would have cotangent of x equals 1 over square root of x. Okay, now we're going to rewrite this in terms of tangent only. So this is going to be 1 over tangent of x equals 1 over square root of 3. And now if you flip both sides of this equation, you will get tangent of x equals square root of 3. That's what we would get. Okay, so that's easier. This equation is definitely easier than that. And now all we have to think is which angle satisfies this equation. If this value wasn't the value of an angle of one of the special trig values, then we would use a calculator for this. But this one again is a special value. So there is a special angle that when you take the tangent of that angle, you do get square root of 3. So what is that angle? Do you remember? What is it? It is pi over 3. Okay, this is just a coincidence that all these examples have been giving me pi over 3. All right, pi over 3. Okay, so pi over 3. That's one angle. To find another one, when it comes to tangent, the other one in the unit circle is going to be actually obtained by adding just pi. When it comes to tangent, it's a little bit different because tangent is a division of sine by cosine. So if that's one angle, the other one is actually over here. Why? Because this point right here has exactly the same coordinates, but both negative, exactly the same coordinates. So when you divide, you're going to get the same value, the same division. So if this one is pi over 3, this other one is just 4 pi over 3. Note that actually is just, as I said, the other angle you obtain by just adding pi. So now, normally then, you would say, okay, the solutions are, you take one angle and say pi over 3 plus the period. Now, this is not 2 pi, this is tangent, so the period is pi, so you say pi n, and then do the same for the other angle. Now, but because this one is obtained from that one by adding pi, means would be a special case, like if you plug in n equals 1 here, you would get 4 pi over 3. There's some redundancy here. Okay, there is some redundancy here. This is redundant. It is correct, but it is redundant because of that. So in the case of tangent, then, you will get, it is better to say that the solution would be, just take this one and add pi in. So this is the actual solution. Okay, and that's because, again, one more time, this solution is already obtained by adding the period. Is already obtained by adding the period. So this is just redundant because this is all solutions obtained from pi over 3 by adding the period, multiples of the period. So, and since this is already one of them, this is already contained in here. This is then what we would say is redundant. This is redundant. Okay, so this is the solution. Where again, n is any integer. Okay, and again, this is better. Okay, let's take a look at this one. It says 2 sine squared plus sine of x equals 0. Okay, now this is getting more interesting. Now you have more than one sine. You have sine squared and sine. But then this type of equation like this, you solve it just like you would with the same methods or techniques that you would solve equations in college algebra. So if you think about it, sine can be treated like a variable. So if I say y equals sine of x, then saying 2 sine squared plus sine of x equals 0 would be the same as saying 2y squared plus y equals 0. And we know how to solve that equation from college algebra. So the good news is then the same techniques work. To solve this in college algebra, this is a quadratic equation. You could either factor or use a quadratic formula. So we can do actually the same thing here. We can either factor or use the quadratic formula. I'm going to factor it because that's easier in this case. So let's say this is going to be, if you factor out the sine of x, which is repeated, factor out the sine of x, you would get sine of x times, and then inside, 2 sine of x plus 1 equals 0. Sine of x is repeated. Factor it out. Then, what do? If you remember, again from college algebra, if you factor out the y, the next thing is you set each of the factors equal to 0. So we're going to do exactly the same thing. You have two things that are being multiplied together and give you 0. So that means at least one of them is 0 or both. So the next thing we do is we set them equal to 0. So sine of x equals 0 or 2 sine of x plus 1 equals 0. And now we solve each of these. Sine of x equals 0. So what are the values of x that give you sine of x equals 0? X equals 0. Okay, x equals 0. And then because the zeros repeat with period pi, this is it. Was in the guidelines because the zeros repeat with period pi. That means that all the other numbers for which you get sine of x equals 0, all the other angles, you obtain them from this one by adding the period. So plus pi n, multiples of the period, plus pi n. And simplifying, this is just x equals pi n. Okay, so that's part of the solution. Now let's solve this one and obtain all the solutions from this piece. Okay, move the 1 to the other side. You're going to get 2 sine of x equals negative 1. Then divide by 2, you're going to get sine of x equals negative a half. And then find all the angles whose sine equals negative a half. The sine equals negative a half. Okay, let's see. I know the angles whose sine equals a half. That would be pi over 6, which is 30 degrees. I don't want positive a half, I want negative a half. Sine is a y coordinate, so I want this angle instead. So what is this angle? This is 2 pi minus pi over 6, which is 11 pi over 6. Okay, 2 pi minus pi over 6, which is 11 pi over 6. So that's one. The other one in the unit circle that has the same y coordinate would be right here, would be this one. This point. And what is this point, this angle? What is that angle? That angle, what is that one? So that would be pi plus pi over 6, which is 7 pi over 6. So that's the other angle that has the same y coordinate, or in other words, the same value of sine. So then we would get that these are two solutions. X equals 7 pi over 6 or x equals 11 pi over 6. So now we found all the solutions in the unit circle, and to find all the solutions in general, add the period. So this is plus 2 pi n plus 2 pi n. Okay? Remember again the difference why we added 2 pi n here and 2 pi n here, but only pi n here. That's because that's the zeros. This is, in this equation, we're looking for the values of x for which the sine equals 0. So that means we're talking about the zeros of sine. And here, we're looking for values of x for which sine of x equals negative a half. This is not a 0. Okay? So when it's not a 0, we add 2 pi. Okay, so now we have all the solutions. All the solutions will be these two. That one and that one. So these three. That, so these two boxes. Pi n, 7 pi over 6 plus 2 pi n, 11 pi over 6 plus 2 pi n. Example number 5 says solve the equation 2 sine squared of x minus sine of x equals negative 3 on the interval between 0 and 2 pi. Okay, so again, this is an equation that could be treated just like the equations that you would encounter in college algebra, because the sine of x is like one entity. So this equation then would be solved very similar, in a very similar way to how would you solve 2y squared minus 5y equals negative 3. Because the sine of x is like our unknown. It's actually our unknown, so it's like a variable. So if you know how to solve this one, then you can solve this one similarly to start it off with. This is what is called in college algebra. This is a quadratic equation, but when you have another expression in terms of just, instead of just one single variable, such as this, sine of x, this is what we called in algebra quadratic type equation, or an equation in quadratic form. So we're going to solve it just like we solve quadratic equations. Alright, so let's start off by moving the negative 3 to the left. So we would get 2 sine squared of x minus 5 sine squared of x, sine of x plus 3 equals 0. Alright, now again, this is like having 2y squared minus 5y plus 3 equals 0. Okay, so what you will try to solve this is try to factor it or use the quadratic formula. Either one. Okay. I think we can try factoring this one. So this one factors as like this, let's see, and then you would put a minus and a plus. Yes, this one factors like this. So what that means is that this one then factors like this. 2, instead of y, you put sine of x plus 1 sine of x minus 3 equals 0. Alright, good. Now, once you have factored in, you have a product of two things equal to 0, that means one of them is 0. So you take each of them and set them equal to 0. And then solve each of them. Let's start with this one. This one says sine of x minus 3 equals 0. Then move the 3 to the right hand side, and this is going to be sine of x equals 3. And this has no solution because sine of x, no matter what angle you put in there, sine of x is always between negative 1 and 1. Remember the graph? It is always between negative 1 and 1. Always between negative 1 and 1. So that means you could never have sine of x equal to 3. That's impossible. So that means this has no solution. Okay, and you can see that because remember how to solve equations like this. X would be sine inverse of 3. So this is like another way of saying that. And that is nonsense. Okay, this will give you error in the calculator. Again, there's no solution because sine of x can never be 3. It can only be numbers between negative 1 and positive 1. So this side has no solution. Now let's work out this side. Move the 1 to the other side, so you will get 2 sine of x equals negative 1. Divide by 2, so you will get sine of x equals negative 1/2. And this one is one that we actually just solved. So instead of doing it again, I'm just going to get the results from the previous problem. So the answer, the solution to this equation that we just encountered again, is 7 pi over 6. Now, note that I'm not copying the 2 pi n. If I were solving the equation in the whole real line, I would copy the 2 pi n too. I would write plus 2 pi n plus 2 pi n. However, I'm not doing that in this problem because it says find the solutions on the interval between 0 and 2 pi. That means in the unit circle. And those are the solutions in the unit circle only. Okay, so that's the answer.